More properties of logarithms. The product property for logarithms can be used to add two logarithms that have the same base. Product property for logarithms. For x is greater than 0, y is greater than 0, b is greater than 0, and b not equal to 1, log base b of x plus log base b of y equals log base b of x times y. In words, the sum of logarithms is the logarithm of the product of their inputs. In this example, simplify, write the result as a single logarithm with a coefficient of 1. Log base b of 5x plus log base b of x. Since we have addition and the same base, b, I can combine the logarithms into log base b of 5x times x, which is equal to log base b of 5x squared. More properties of logarithms. The quotient property for logarithms can be used to simplify the difference of two logarithms that have the same base. The quotient property for logarithms for x greater than 0, y greater than 0, b greater than 0, and b not equal 1, log base b of x minus log base b of y equals log base b of x divided by y. In words, the difference of two logarithms is the logarithm of the quotient of their inputs. In this example, simplify, write the result as a single logarithm with a coefficient of 1. Log base b of 10x minus log base b of 5. Since they both have the same base, I can write this as log base b of 10x divided by 5, reducing, I have log base b of 2x. In this example, we still want to simplify. I have 4 log base b of x squared plus 5 log base b of x. For this problem, I'm combining my power property with my product property. Step 1 is to rewrite the logs with the power. So I'm going to take the 4 in front and rewrite it as a power. Log base b of x squared to the 4th power plus, and now I'm going to take the 5 and write it as a power. Log base b of x to the 5th. If I simplify this, I have log base b of x to the 8th plus log base b of x to the 5th. And now I'm ready to use the product property. Log base b of x to the 8th times x to the 5th. My final result, log base b of x to the 13th. In this example, I want to simplify log base b of 6x to the 4th minus 7 log base b of x. First thing I need to deal with is this 7. So I have log base b of 6x to the 4th minus log base b of x to the 7th power. Now I can rewrite it using the quotient property. Log base b of 6x to the 4th divided by x to the 7th, reducing, I have log base b of 6 over x to the 3rd. Solving logarithmic equations. In this example, solve, round any solutions to the 4th decimal place. The only difference between what we've been doing and what we're doing now is we have an equality. So we have to find, in this case, x. My original problem is log base 2 of 4x plus log base 2 of x equals 5. My first step is to write this as a single logarithm. Log base 2, 4x times x is 4x squared equals 5. I need to solve for x. It's written in logarithmic form. We want to write it in exponential form. So it changes to 2 to the 5th power equals 4x squared. And we can now just solve it for x. So I have 32 equals 4x squared. Divide both sides by 4. 8 equals x squared. I can take the square root of both sides. Calculating. I have the square root, so second x squared of 8 gives me 2.8284. 2.8284 equals x. So x equals 2.8284. In this example, we want to solve and round any solutions to the 4th decimal place. Log base 7 of 12x minus log base 7 of 6 equals 2. Our first step is to use our quotient property to combine this into a single logarithm. Log base 7 of 12x divided by 6 equals 2, which means I have log base 7 of 2x equals 2. Ready to write it from logarithmic form to exponential form. 7 squared equals 2x. I divide both sides by 2. 49 divided by 2 equals x. If you need to calculate, 49 divided by 2 gives us 24.5. X equals 24.5. In this example, we want to solve 4 log 2x minus 3 log of x squared equals 3. So our first step is to deal with the power. So that gives me log of 2x to the 4th power minus log of x squared to the 3rd power equals 3, which gives me log 16x to the 4th minus log x to the 6th equals 3. Combine them as a single logarithm. I know I'm going to divide. 16x to the 4th divided by x to the 6th will give me 16 over x squared. So I'll have log of 16 over x squared equals 3. And now I'm ready to write it in exponential form. I'm dealing with log base 10 to the 3rd power equals 16 over x squared. 10 to the 3rd power is 1,000 equals 16 over x squared. Because my x is in the denominator, a quick way to solve it would be to write 1,000 over 1 and cross multiply. That gives us 1,000 x squared equal to 16. Divide both sides by 1,000. X squared equals 16 over 1,000. I can square root both sides. X equals the square root of 16 over 1,000. Calculating. Second, x squared for my square root. 16 divided by 1,000. Enter. 0.12649, which rounds to 0.1265. So x equals 0.1265. In this example, we want to solve 2 log base 3 of x squared plus 3 log base 3 of 2x equals 4. So our first step is to deal with the powers out in front, which gives me log base 3 x squared to the second power is x to the fourth plus log base 3 of 2x to the third power is 8x to the third equals 4. Now I'm ready to write this as a single logarithm. Since x to the fourth times 8x to the third is 8x to the seventh, my log becomes log base 3 of 8x to the seventh equals 4. I'm ready to rewrite this in exponential form. 3 to the fourth power equals 8x to the seventh. Dividing both sides by 8, 3 to the fourth power is 81, divided by 8 equals x to the seventh. Now I want to take each side to the 1/7 power. So x equals 81 over 8 to the 1/7 power. Now we're ready to calculate. Parenthesis, 81 divided by 8, exponent, parenthesis, 1 divided by 7, enter. I get 1.39196. I need to round that to 4 decimal places. So x equals 1.3920. Change of base property. The log key on our calculator finds logarithms base 10. The change of base property is used to find logarithms for bases other than 10. Change of base property. For a greater than 0, b greater than 0, a not equal to 1, b not equal to 1, and x greater than 0, log base b of x equals log base a of x over log base a of b. In this example, we want to evaluate and round your result to the 4th decimal place, log base 3 of 7. So using our change of base property, I want to choose for my base a to be 10. So log of 10 of, in the numerator, you want what's in your parentheses, 7, divided by log base 10 of 3. Calculate. Type log 7, close your parenthesis, divided by log 3, close your parenthesis, enter, and we get 1.771243749. Rounding to the 4th decimal place, I have 1.7712. In this example, we want to evaluate, round your result to the 4th decimal place, log base 1/2 of 7. Again, we want to use base 10, so I have log of what's in my parentheses, 7, divided by log of my base, which is 1/2. Now I'm ready to calculate. So we type log 7, close parenthesis, divided by log 1 divided by 2, close parenthesis, enter, and we get negative 2.807354922. Rounding our result to 4 decimal places, we have negative 2.8074. More properties of logarithms. We have our product property that tells us if we have log base b of x plus log base b of y, it can equal log base b of x times y. We also have our quotient property of logarithms that tells us if we have log base b of x minus log base b of y, that equals log base b of x divided by y. We can solve logarithmic equations by using our power property, our product property, and our quotient property to rewrite our logarithms so that we have it in logarithmic form. Then we can rewrite our logarithmic form in exponential form and solve for our variable. The change of base property allows us to rewrite our logarithms with base 10, so it's easily calculated on a scientific calculator. If we have log base b of x, we can rewrite that as log base b of x divided by log base a of b.